Good day, professors. I am Chino Ledres and my thesis partner, Ellaine Villegas. We will be presenting our study entitled Physical Assessment and Perceived Quality of E-jeepney in Metro Manila. So for the introduction, I will be discussing about the background of the study, review of related literatures, objectives, and scope and limitations. Beginning with the study's background, a shift in the transport industry has been widely promoted by the government, as they believe it aids to boost the country's economy, with the assistance of technology in the vehicular scope, particularly in the mode of public transportation. The phase of adapting from traditional jeepneys to clean and modernized vehicles has been progressively surfacing in the country, with the issues of discomfort and other problems in the transport sector. The DOTR launched the PUV modernization program in the year 2017 to address these claims and sustainability aspects. According to DOTR Secretary Tugade, the modernization is designed to strengthen profitability of the jeepneys. In an article entitled Reforming the Semi-Informal Minibus System in the Philippines, the regulations under the modernization program was discussed. This includes the phasing out of the aging vehicles, which exceed the allowable years to be in operation, routing services, changes in franchising, and other standards. The PUV modernization program promulgated standards in emission and safety, which includes the use of renewable energy or Euro 4 emissions to address the environmental concerns and sustainability, installation of surveillance camera and GPS as preventive action from theft and manner of driving, and adaptation of automated fare collections or the AFCS for cashless payment. The reform in terms of franchising condition is mandated by the government. The Department of Transportation's Department Order Number 2017-011 governed the 5 principles of public transport, which require compliance upon the service of public transit. Reliability covers the quality of transit service in terms of its punctuality and availability. In terms of safety, requirement of surveillance equipment is considered. The accessibility involves convenience and concerning the boarding and alighting of commuters. And for the environmental soundness, concerns with the compliance of standard emissions and comfort fits the quality of seating room. These 5 principles were also considered by the researchers as measurement indicators. To strengthen the study's foundation, literatures relevant to the topic were used. More related literatures can be found on the manuscript. The study of Wang and Zacharias on the perception of the passengers on the physical environment of the vehicle will be used by the researchers to consider these factors during the vehicle assessment. With a broad definition of comfort, other related study by Imre and Celebi discuss the factors to measure the ride comfort, which pertains to relevant facilities and ergonomics. A study by De Vecchi discussed the utilization of design tool like QFD to translate the design requirements based on the needs of the passenger resulted from the satisfaction survey to translate it into an actual specification of the public transportation. A local literature by Cause assessed the driver's workspace of the jeepney and determined the factors to consider in vehicle assessment, which includes the dimension of vehicle components and the area of the occupant. Here were the 4 objectives of the study. First, to determine the passengers' and drivers' perception of the existing electric jeepney to measure their level of satisfaction. Second, to evaluate the current specifications of the e-jeepney based on the principles of public transport, such as in terms of reliability, safety, accessibility, environmental soundness, and comfort, and check whether they comply or within standards. Third, assess the relationship between the perception of respondents on e-jeepney and the measurement indicators considered for evaluation. And lastly, recommendation of relevant improvements based on the results of the assessment. Here were the scope and limitation of the study. Go Electric Jeepney, operated by the Transport Service Cooperative at PITX Terminal. Respondents will be participated by drivers and passengers of the Go Electric Jeepney. And the assessment is only limited to design interior components of E-jeepney and will not cover the mechanical variables. We will be discussing two parts of the methodology: the phases of conceptual framework and discussion of tools. These were the phases for the conceptual framework. In phase 1, a total of 268 respondents consisting of passengers and drivers were asked to participate in the study. The survey covered the 5 indicators established in order to determine the perception of respondents. Their perception was determined using analysis of variance as statistical analysis. They were also interviewed regarding their needs and design preference of E-jeepney. For phase 2, qualitative assessment was conducted to be able to gather the data to validate the resultant perception of respondents. In terms of quantitative assessment, the actual dimensions of the physical components and other design aspects were measured. Link system and mismatch analysis were also utilized by the researchers to compare if the dimensions accommodate the anthropometric data of Philippine user. In the third phase, regression analysis was utilized in the process to determine the relationship between the perception of the respondents and determinants established for each assessment criterion. Also in the third phase, strengths and weaknesses were then enumerated. The weaknesses were subjected to improvements. Lastly, for phase 4, using design tools such as QFD, cost-benefit analysis, and FIMEA, the researchers were able to recommend improved specification of E-jeepney.
The survey covered the 5 criteria to be rated by the respondents based on their satisfaction level. The survey consisted of 3 sections. Section 1 is intended for passengers, while Section 2 is intended for drivers. Section 3 is intended for both drivers and passengers, since this required the overall rating on the 5 indicators. One-way ANOVA was also used to analyze the perception of respondents on the specific determinants of each indicator established. A rubric of satisfaction level was utilized, whereas the highest qualitative rating is very satisfied, while the lowest qualitative rating is very dissatisfied. To use the link length system, the researchers utilized the stature height of the 268 respondents who used the E-jeepney. The actual height measurement was multiplied by the ratio corresponding to the relative anthropometric measurement which the researchers considered in this study. The 5th and 95th percentiles were also computed by using the standard formula. The equation to determine the 5th percentile is mean minus 1.645 times standard deviation, while the equation to determine the 95th percentile is mean plus 1.645 times standard deviation. Before the acceptability of the link length system, the researchers used t-test for statistical analysis to determine if there was a significant difference between the 14 samples of actual body part dimensions that were measured and its resulted body dimensions from the link system based on the stature height of these samples. Once resulted non-significant, the link length system was used. The goal for the mismatch analysis was to identify if the existing dimensions of the E-jeepney accommodated the set standard anthropometric measurements of Filipino users within the 5th and 95th percentiles. To utilize the multiple linear regression, the researchers used the determinants of the criteria as the independent variables, and the overall rating of respondents in terms of the 5 criteria as the dependent variable. An interview with a focus group consisting of 14 people who have used the E-jeepney was conducted in order to gather their needs and preferences when it comes to service and design aspects of an E-jeepney. The quality function deployment was used to determine the prioritized specifications subjected for improvements. In cost-benefit analysis, the researchers enumerated the benefit associated with satisfaction to be experienced by the future users of the proposed E-jeepney's relevant specifications. The failure mode and effects analysis was applied to review and determine the possible failures that might have existed on the improvements that were recommended. The researchers also created a failure mode and effects analysis scale for severity, occurrence, and detection ratings. In terms of severity, the scores were based on the impact of the effect caused by the mode of failure on the quality of comfort experienced by the users of E-jeepney. While for the occurrence scale, the occurrence scores were based on the probability that the cause would occur. Lastly, the detection scores were based on the ability of the current control to detect either the failure effect or mode of failure. The scores resulted from the mentioned 3 criteria were used for the computation of the risk priority number or RPN.
We will now be discussing the results and discussion. Based on the tabulated results above, passengers were satisfied with safety and resulted with the high satisfaction mean rating of 3.64, while they were neither dissatisfied nor satisfied with comfort, which also resulted with the lowest mean rating of 3.20. The Tukey's test suggested that safety was significant with environmental soundness, with a p-value of 0.042, significant with comfort and reliability, which has a p-value of 0. It was also confirmed that comfort was significant to the other criteria, with a p-value of 0.000. The passengers were satisfied with predictable travel time, which also resulted as the highest determinant under reliability, with a mean rating of 3.66, while the lowest determinant was waiting time at the station with a mean rating of 2.78, which passengers were neither dissatisfied nor satisfied as perceived. Using the Tukey's test, the highest and the lowest reliability determinants were confirmed, since the determinants were significant to each other with a p-value of 0. The passengers were satisfied on the handrails attached in E-jeepney, and resulted as the highest determinant under the safety criterion, with a satisfaction mean rating of 4.11. On the other hand, they were dissatisfied on the CCTV camera to monitor in and around the vehicle, with a mean rating of 2.36, which resulted to be the lowest safety determinant. The satisfaction results were proven using Tukey's test, which showed that the 3 determinants were significant to each other with a p-value of 0. The passengers were very satisfied with the designated stops, pick-up and drop-off points resulting in the highest satisfaction level among the subfactors of accessibility, with a mean rating of 4.36, while accessibility by senior citizens and disabled resulted in the lowest satisfaction level, wherein passengers were neither dissatisfied nor satisfied with a mean rating of 2.88. Moreover, it was analyzed that the different determinants were significant to each other with a p-value of 0. The use of renewable energy and energy with lower air pollutants resulted as the highest determinant with a satisfaction mean rating of 4.92, where passengers were very satisfied as perceived, while they were neither dissatisfied nor satisfied on the ventilation inside the E-jeepney during travel time. Using the pairwise test, it was analyzed that E1 was significant to other determinants with a p-value of 0. Additionally, E2, as the lowest determinant with a mean rating of 3.02, was significant to other determinants as well with a p-value of 0. The passengers were very satisfied on the aisle space when entering and descending the E-jeepney, wherein it also resulted as the highest determinant under the comfort criterion, with a mean rating of 4.58, while they were dissatisfied on leaning the back when riding the E-jeepney. Using the pairwise test, it was analyzed that C2 was significant with other determinants with a p-value of 0, while C4, with the lowest mean rating, was significant with other determinants with a p-value of 0, but not with C6 with a p-value of 0.697.
Based on drivers' perception, the drivers were satisfied with the E-jeepney service reliability as it also resulted with the highest mean rating at 3.50. Second in rating was safety and accessibility, which then followed by the criteria of environmental soundness. The drivers rated comfort with the least mean rating of 3.00. However, the different criteria were not statistically significant with p-value of 0.173. As shown in the results, the drivers rated the reduced waiting time as the highest determinant with a mean rating of 4.33, and they were very satisfied in terms of perceived quality. On the other hand, the availability of E-jeepney on surrounding areas was the lowest determinant with a mean rating of 3.50, where drivers were satisfied as perceived. Using the simultaneous test for differences of means, it was confirmed that R1 was significant with R3 with p-value of 0.001 and significant with R4 with p-value of 0.028. Moreover, the Tukey's test also suggested that R3 was significant with R1 with p-value of 0.001. The drivers were neither dissatisfied nor satisfied on the dashboard camera, but resulted in having the highest mean rating of 3.00. They were dissatisfied on S2 with a mean rating of 2.67, while the lowest mean rating of 2.40 was obtained by S1. The analysis resulted statistically not significant. The drivers were very satisfied on the designated stops, pick-up, and drop-off points, which showed as the highest determinant with a mean rating of 4.83, while they were satisfied with accessibility by senior citizen and disabled, but resulted as the lowest determinant with a mean rating of 3.56. Moreover, it was analyzed using Tukey's test that all the safety determinants were significant with each other with p-value of 0.000, which confirmed that the above rating are significantly different from each other. The drivers were very satisfied on the use of renewable energy and energy with lower air pollutants, which also resulted as the highest determinant with a mean rating of 4.68. On the other hand, they rated ventilation while inside the E-jeepney during the travel time as the lowest determinant of environmental soundness criterion with a mean rating of 2.89 and perceived neither dissatisfied nor satisfied. E1, being the highest satisfaction rating, showed significantly different from each other with p-value of 0.00, while E2, with the lowest satisfaction rating, also showed significantly different from each other with p-value of 0.00 as well. Based on the driver's point of view, they were satisfied on leaning the back when driving the E-jeepney, which also resulted in the highest mean satisfaction rating of 4.17, while they perceive adjustable driver's seat dissatisfied in terms of quality and had the lowest mean rating of 2.28. The determinants with satisfied ratings and dissatisfied ratings are significantly different with each other with p-value of 0.00.
The tabulated data shows the current dimensions of the E-jeepney's passenger cabin that were measured during the physical assessment at the terminal. The isometric view of the E-jeepney is shown on the figure located at the right portion. The tabulated data shows the current dimensions of the E-jeepney's area for driver that were measured during the physical assessment at the terminal. More views of the E-jeepney were shown in the manuscript.
The table shows the summarized samples of actual body dimension and corresponding link length. Based on the results, it was analyzed that the actual body dimensions of the respondents were not significant with the equivalent link length as suggested by the p-values, since the p-values were all greater than 0.05. This means that the null hypothesis was accepted. Being not significant, this validated that the researchers could use the link length system for the anthropometric data used in the study. The table shows the summary of link length system of passengers. It also contains the computed 5th and 95th percentile dimensions that were considered as a standard dimension to be accommodated by the passenger cabin. The computed 5th and 95th percentiles of the drivers were also based on the formula applied, and resulted values were considered as standard dimensions to be accommodated by the design parts of the driver's workspace. The table presents the mismatch analysis between the current dimension of passenger cabin and standard mean anthropometric measurement computed from the link length system. Based on the results, the seat width, backrest height, and overhead grab rail height were the existing dimensions that were not accommodated by the standard dimensions. The table presents the mismatch analysis between the current dimension of workspace for driver and standard mean anthropometric measurement computed from the link length system. Based on the results, the dimensions which needed recommended improvements based on their respective remarks were aisle width, height of the windshield, and the distance of foot controls.
The table presents the mismatch analysis between the current dimension of passenger cabin and standard mean anthropometric measurement computed from the link system. The seat width, backrest height, and overhead grab rail height were the existing dimensions that were not accommodated. For the reliability criteria, determinants with the highest and lowest mean ratings were waiting time and availability of e-jeepneys on surrounding areas. The qualitative assessment for the waiting time. Normally, the range of waiting time at the terminal base on the interview with the passengers was 15 to 30 minutes before the boarding. In the driver's point of view, their waiting time to load completely before the pandemic was in range between 5 to 10 minutes. For availability of e-jeepney on surrounding areas, these were the number of e-jeepneys per route. For PITX to Alabang, for e-jeepneys, for PITX to West Bicutan, for e-jeepneys, PITX to East Bicutan, also for PITX to Sukat, 3, and from PITX to Nichols, it's also 3. For the safety criteria, the determinants with the highest and lowest mean ratings were dashboard camera when driving, removal of cash usage for payment, handrails attached in e-jeepney, and CCTV camera to monitor in and around the vehicle. So for the qualitative assessment for each of the determinants, dashboard camera when driving, there was a dashcam installed inside the e-jeepney but not always working. For the removal of cash usage for payment, there was an installed tap card technology in the e-jeepney but it's not working. Handrails attached in e-jeepney. The handrails attached on the e-jeepney was plain parallel rails and there were no safety grab rails attached on the handrails for standing passengers. Lastly, for CCTV camera, to monitor in and around the vehicle, the CCTV cameras were present but not working all the time. It is based on the interview with the passengers. For the accessibility criteria, these were the qualitative assessment for each determinants. For the designated stops, pick up and drop off points, there are designated stops and pick up and drop off points in each route taken by E-jeepney. Accessible by senior citizens and disabled, there were no priority seats, and the clamp rails for easy grass were limited. For environmental soundness, the determinants were use of renewable energy, ventilation, while inside the Egypt. The qualitative assessment for the use of renewable energy, the nature of vehicle is electric and rechargeable. There was no gas emission. For ventilation, during the assessment, the windows were widely open and no window rails. There were no blower fans installed inside the e-jeepney. And lastly, for the comfort criteria, the determinants were leaning the back when driving, adjustable driver seat, aisle space when entering the descending e-jeepney. So the qualitative assessment for each of the determinants. So for the backrest, leaning the back when driving, a backrest cushion was provided for drivers but not for passengers. For adjustable driver seat, the driver seat on the e-jeepney was not adjustable as assessed. And lastly, the aisle space when entering the descending the e-jeepney, as observed during the assessment, at the most, two passengers could pass at the same time within the aisle clearance.
The table shows the summarized determinants with the highest and lowest coefficients using regression analysis based on passengers' perception. In terms of reliability, the schedule of available e-jeepneys operating is the highest contributor to the overall rating model, while waiting time at the station was the lowest. The negative coefficient implies that the ratings of passengers on the waiting time determinant is decreasing. In terms of safety, the CCTV camera to monitor in and around the vehicle is the highest contributor to the overall rating model, while the handrails attached on e-jeepney was the lowest. The determinant of the handrails attached on e-jeepney has a negative coefficient, which means that the ratings of the passengers is decreasing. In terms of accessibility, the highest contributor to the overall rating model is the point-to-point route destination, while the lowest is accessible by senior citizens and disabled. While for environmental soundness, the highest contributor to the overall rating model was the level of lighting, while the lowest is the sound level. Lastly, in terms of comfort, the highest contributor to the overall rating model was the leg comfort, while the lowest is the leaning the back when riding the e-jeepney with a negative coefficient, which means that the passengers' ratings are decreasing. The table presented shows the summarized determinants with the highest and lowest coefficients using regression analysis based on driver's perception. In terms of reliability, the determinant with the highest contribution to the overall rating model was the predictable in terms of travel time, while the lowest was reduced waiting time at the station with a negative coefficient, which means that the driver's ratings were decreasing. In terms of safety, the highest determinant was removable of cash usage for payment, while the lowest determinant was GPS installed to enable recording of vehicle location with a negative coefficient, which also means that the driver's ratings on the GPS installed were decreasing. On the other hand, in terms of accessibility, the designated stops, pick up, and drop off points resulted to the highest contributor in the overall rating model, while the point-to-point route destination resulted to the lowest contribution in the overall rating model. In terms of environmental soundness, the ventilation while inside the e-jeepney during travel time was the highest contributor to the overall rating model, while the use of renewable energy and energy with lower air pollutants resulted to the least contributor in the overall rating model with a negative coefficient, which means that the driver's ratings on this determinant for decreasing. Lastly, in terms of comfort, the seat material for driver's seat has the highest contribution to the overall rating model, while the leg comfort has the least contribution. With the mean coefficient of negative 0.368, it means that the driver's ratings on the leg comfort were decreasing.
The table shows the strengths and weaknesses of E-jeepney based on the 5 principles of public transport. This was also the basis for the overall improvement of the E-jeepney by addressing the weaknesses. Attributes associated with comfort resulted in having the highest importance ratings, which includes the size of passenger seating room, height of backrest, adjustable driver's seat, distance of steering wheel, distance of foot controls, vertical distance of the steering wheel, driver's aisle clearance, overhead grab rail height, and height of the windshield. The lowest ratings resulted on the attributes associated to safety. An importance rating of 110 implied to be the attribute to be most prioritized. The table shows improved specification of passenger cabins dimension. The improved specifications use the standard mean data resulted from length system. Refer to manuscript for the proposed design of passenger cabin, which shown from figure 11 to 13.
The table shows improved specifications of dimensions for driver's workspace. The recommended specifications use the standard mean data resulted from the linked length system. Refer to manuscript for the proposed design of driver's area, which is shown from figures 15 to 19. As shown in the cost-benefit analysis, the total cost for the proposed design of E-jeepney, including the electric vehicle and customization, is 2,090,500 pesos, whereas the total cost for customization was added to the current E-jeepney's cost. It resulted to 11% increase on the E-jeepney's price, but the recommended specifications would contribute to an increase on the user's level of satisfaction when riding and driving the E-jeepney. As shown in the cost-benefit analysis, the total cost for the proposed design of E-jeepney, including the electric vehicle and customization, is 2,090,500 pesos, whereas the total cost for customization was added to the current E-jeepney's cost. It resulted to 11% increase on the E-jeepney's price, but the recommended specifications would contribute to an increase on the user's level of satisfaction when riding and driving the E-jeepney.
Design input which conceive a rating of 6 or 10 on severity, occurrence, and detection based on failure mode and effects analysis. Design standard length of cabin seating room to make passengers sit comfortably. Added backrest cushion. Suspended grab rail attached on handrail bar. Adjustable driver seat. Backrest with lumbar support. Added headrest. Working CCTV inside the E-jeepney. Enabled automatic fare collection system. Functioning dashboard camera with GPS. And detachable mechanical rump. For the conclusion of this study, passengers and drivers were neither dissatisfied nor satisfied on the comfort experience with the current design of E-jeepney, and resulted continuous low satisfaction ratings from both respondents. Among the measurement indicators, Safety criterion was rated by the passengers with the highest satisfaction rating and satisfied as perceived, while it was service reliability for drivers. Most of the dimensions of the passenger cabin accommodated the corresponding population for each cabin part of the E-jeepney. Driver's workspace obtained more unaccommodated standard dimensions, which can be concluded that the driver's scope required more improvements. It can be concluded that the determinants used under each criterion are essential in the overall satisfaction rating of each jeepney's user, since the behavior of the ratings given by the respondents reflect on the overall rating model. Most of the improvements on e-jeepney were in terms of comfort, environmental soundness, and accessibility, whereas anthropometric principle was considered, while other design input required compliance with operating equipment installed in e-jeepney to address reliability and safety.